chapter 10, we are going to talk about matrices. Okay, so I'm going to give you this matrix M. I'm going to use letters for now, okay, but there will be numbers here eventually. I'm going to call it A, B, C, D. Okay, go ahead and write that down. This matrix, okay, is made up of brackets that kind of enclose the matrix, and then this A, B, C, D, those are elements in the matrix, or terms in the matrix, okay? How many terms are there right now? There's 4, okay? What we're going to refer to matrices as is a combination of rows and columns. Okay, so what is a row? Is it side to side or up and down? Side to side, right? So I'm going to write row this way, because row is side to side. Okay, what's a column? Column is up and down. How do you think I'm going to write column? Up and down. Yep, this is a column. Okay. Matrices are made up of rows and columns. Okay, how many rows are in this matrix that I made? 2. Yep, there's one here, one row going side to side, and there's another row going side to side. Okay. How many columns are there? There is also 2. There's one column going up and down, and then there's another going up and down. Okay. This matrix, okay, it's named after its rows and its columns. Okay, so how they name them is its number of rows by, that is a multiplication sign, okay, but we read it as by, okay, number of rows by number of columns. So, in this matrix, how many columns did we say there were? There's 2 columns by how many there was 2 rows. How many columns are there? 2. So, this is a 2 by 2 matrix. Okay, that's its name. Okay? 2 by 2 matrix. Okay? I want you to know that these values can be anything. Okay, there can be a 5 by 5 matrix. Okay, there can be a 10 by 12 matrix. Okay, it can go up all the way to a 100 by 200 matrix. Okay, matrix can be made up of however many columns and however many rows. Okay, so I'm going to give you another matrix down here. I'm going to put random numbers in it. Give me a name for this matrix. Go ahead and write it down, then we'll talk about it. Okay, so I'm going to start with row, and I'm going to stay color coded up at top. Row is side to side, right? So how many rows do I have?
3.
Rows are side to side. So I have 1, 2, and 3. So I have 3 rows by, columns are up and down. How many columns do we have? 2. Yep, so this is a 3 by 2 matrix. Okay, you are never going to name these from columns to rows. Okay, it's always going to go rows to columns. Okay, so always have, maybe write that down. Always have rows first, columns second. So go ahead and write this matrix down off to the side of example 1, matrix A. Now let's talk about what can we name this matrix. How many rows?
3.
Has 3. So we have 3 rows by how many columns? 2 columns. Yep, rows are side to side. Columns are up and down. Okay. Now we're going to talk about specific elements in a matrix. Okay, so yes, this is the name, a 3 by 2 matrix. Okay. Now we're going to talk about elements. So go ahead and write this down. Okay. A, they just use this as a generic term to label an element or a term in a matrix. Okay, so A of, I'm going to say 2, 3. Okay, that does not say 23. Okay, it means A of 2, 3. And what this means, okay, that 2, what usually comes first, rows or columns? Rows come first. Yep, so 2 is row 2. What do you think 3 is? Column 3. Yep. So it wants to know what term is in row 2, column 3. Oh, I did this last period too. What do you notice I did? Is there such thing as column 3? No. Flip-flop these. Make it 3, 2. That's my bad. Make this 3, 2. So what row does it want us to look at? Row 3, column 2. Remember, it's always going to go row and then column. Okay. So row 3 is where? Bottom, right? This is my row 3. Okay. Which one's my column 2? Left or right? On the right, right? That's my column 2. So which term is in row 3, column 2? 8. Yep. So our answer for A32 is 8.
Do we put equals 8?
Yes.
Okay.
Yep. I'm going to give you another one. I'm going to make sure it makes sense this time. Let's do A of 2, 2, 1. Again, let's walk through this together. What is that? Does this say 21? No. What does 2 stand for? Row 2. What does 1 stand for?
Column 1.
Was anyone? Okay. Okay, so this next one, that A of 2, 1, okay, row 2 is here, yes?
Yes.
Column 1 is here, yeah?
Yeah.
Okay, so which one is in row 2, column 1? Negative 2. Yep, equals negative 2.
These are previously 1.
Okay, in your example 1, it wants you to find A of 1, 2, A of 2, 1, and A of 2, 2. What I also want you to do on this one is give me the name of the matrix along with those.
The name?
So how many rows by how many columns. So name it and find those elements. Let's talk about the name first. Remember, name comes from how many rows by how many columns. How many rows do I have? 2 rows by how many columns? 2. So this is a 2 by 2 matrix. Okay. So this first one says A of 1, 2. Let's talk about this. 1 means row 1. 2 means column 2. Which term is in row 1, column 2? 5. Yep. Okay, the second one, A of 2, 1. What term's there? Row 2, column 1. 8. Yep. And then A of 2, 2. What is row 2, column 2? 10. I'm going to ask you an add-on question. Okay, what if I asked you what element is 7? Where is 7 at in our matrix? What row is it in? It's in row 1, column 1. So it would be A of 1, 1. Write that one down. A of 1, 1. Now we're going to talk about scalar multiplication. Okay, we all know what multiplication is, but something we might not be too familiar with is that scalar term. Okay, that scalar term is whatever we're multiplying by. Okay, so in this example up here, not in your notes, up here on the board, it says that our scale is 5%. Think of what we did with exponential growth and exponential decay and compound interest. What did we have to do with those percentages or those rates before we could use it? Divide it by 100. Yep, so if I did 5% divided by 100, that would get us 0.05. Yep. So I'm going to take that matrix C. My scalar is 0.05. And I'm going to multiply it by our matrix. You do not have to write this down right now. And then here's my matrix I was given. Okay. What do you think we do? Do you agree first that this says multiplication? Okay, because they're right next to each other. How do you think I multiply matrices? I'm going to ask you this. If I had 0.05 times x plus 2, what would I do here? I would distribute. What do you think I'm going to do here? I am going to distribute. What am I distributing to? Each term. How many terms are there? There's 6. So I'm going to take this 0.05 to every single term. Every single term. Okay? When I do that, I have to make sure they stay in the same place. Okay, so go ahead and grab your calculators. Help me out here. What is 0.05 times 320? 16. I need to put that 16 in the same spot where that 320 was. Okay. What about 210 times 0.05? 10.5. Can I put that here?
I can't see.
Can I put that here? No. Where does it have to go? It has to be right where that 210 was. Okay, get the idea here? What's going on? Okay, go ahead, take this idea, go do your example 2. Okay, on your example 2, it does give you a different scale factor. What's the scale factor that it gives you? 6%. Where does that 6% turn into? 0.06. Yep, so you're going to take your matrix and you're going to multiply by 0.06. Okay, on this one, what am I going to do with that 0.06? I'm going to distribute to what? Every single term. Okay, again, how many terms do I have here? 6. What's the name of this matrix? Let's do some review. 2 by 3, correct. Yep. So we're starting with the 2 by 3 matrix. Help me out. What's 75 times 0.06? 45. Okay, I'm just going to go left to right. What's 40 times 0.06? 2.4. 25 times 0.06? 1.5. Where do I go from here? I'm going to, do the second row. 100 times 0.06? 6. 60 times 0.06? 3.6. And then 30 times 0.06? 1.8.
So I got all whole numbers. Did I just...
Oh, sorry, this is 4.5. Thank you. I want to compare some things. Here's my original matrix, yes? Okay. What do you notice between that one and our new one?
Our new one's decimals and those are whole numbers.
Okay, first one was whole numbers, next one, some of them are decimals, and it got smaller. Okay, what else do you notice? Okay. We said our first one was a 2 by 3 matrix. What's the second one?
3 by 3.
Did it stay the same or did it change? It did stay the same, right? We still have a 2 by 3.
Yeah.
Okay, so what I want you to understand that even though we're multiplying a matrix by some scalar, okay, it's not changing the size of a matrix. Okay, the matrix is staying the same size whenever you're multiplying. Okay, it's not. All right, now we're going to talk about adding and subtracting matrices. Okay, so here I have 2 matrices. You don't have to write these down. We have 2 matrices here. We have matrix A. This is our matrix A. This is our matrix B. Okay. What are the names of both of those? What are the dimension? I heard 2 by 3. Is that correct from both of them? Yes. So both of these are a 2 by 3 matrix. Okay. So when we add these together, we have to add the same terms in the same spots. So I'm going to start with 14. What term is in the same spot as 14? 18. So we're going to add 14 plus 18 to get our new term here. Yep, we're just making a new matrix here. So I'm just going to jump around here. What would I combine 15 with?
9.
It would be 9, right? Because they're in the same spot. They're both, I'm going to say A of 2, 2. Yeah? So we would combine those to get our new term, 24. Yes? Okay, let's try one more. What about 28? We'll combine with 25, and I'm adding them together, so I would get our new term, 53. What do you notice where that new term goes?
The same spot.
In the same spot. Yep. Same thing with subtraction, except you're just subtracting instead of adding. Yep. Do that. Let's do example 3A, m plus n. Okay, and keep track of those orders. You do not have to rewrite the matrices every time. Okay, so m plus n, okay, I'm going to add together negative 3 plus 6. I'm making a new matrix. Negative 3 plus 6 is positive 3. Yep. I'm going to just go left to right. Now I have 5 plus 5. 10. Next one, I have 2 plus a negative 8. Negative 6. Can I put that negative 6 here? Everyone look. Nope, it has to go in that same spot. And then next one, 0 plus 0.2. 0.2. Yep. Okay. Did the matrix stay the same size? Yes, that's a way to check yourself to make sure it stayed the same size. I want to ask you a side question. Everyone look up here. This is the correct answer. If on a test you gave me this instead, is that correct? No, what's wrong? They're not in the right order. Yep, so be careful of that. The second part of part A wants you to know what n plus m is.
Just the same thing.
It's kind of like, what did you say?
It'd be the same thing.
It's going to be the same thing, right? All this is saying is it just swapped these two matrices. But if I take 6 plus a negative 3, what do I get? The same thing. I still get that positive 3. Same thing as if I had originally, let's put this with numbers. If I had 6 plus 4, what is that? 10. If I swapped those two numbers, 4 plus 6, what do I get? I still get 10. So that's the same thing with matrices also. It does not matter the order that you add them. Okay, so for n plus m, I would still get that same matrix that we got from the beginning. Capiche? All right. Now let's try part B with subtraction. Subtraction's a little more tedious. Okay, we got to be careful. M minus n. So I'm just going to start with negative 3 minus 6. Negative 9. 5 minus 5. 0. 2 minus a negative 8. You got to be a little careful. It is a positive 10. Yep. Because 2 minus a negative 8, what happens to those? Turns to addition. That's how we get 10. Good. And then 0 minus 0.2. Negative 0.2. Yep. Okay. Now, what about n minus m? Is it going to be the same?
No.
Let's check. Let's try. So n minus m, I would have to take 6 minus a negative 3. Let's write that up here. 6 minus a negative 3. Those two negatives turn positive. 6 plus 3 is 9. Is it the same? No, it's not. Let's keep going. What's 5 minus 5? 0 still. Negative 8 minus 2. Negative 8 minus 2. Negative 10. And then 0.2 minus 0. 0.2. So were they the same? No, but what do you notice between these two? They're opposites, right? What's a word that we've used for opposite before? Starts with an I. Inverses, right? Remember, inverses, that means the same thing as opposites. Okay, so those are inverses of each other. Something I want to talk about quick. If I added these two matrices together, let's see what we would get. If I add these two matrices together, so negative 9 plus 9, 0, 0 plus 0, 0, 10 minus 10, 0, sorry, 10 plus a negative 10, and then negative 0.2 plus 0.2. What do you notice? It's all 0. That's called a 0 matrix. Okay? Inverses will get you that 0 matrix, and they call this the identity matrix. Okay? That's called the identity. Okay? What identity means is it gets it back to itself. Okay? So keep that in mind. If we add inverses together, we get that 0 matrix. Okay? I want to look at this example first. It's not in your notes. Okay? Look at these 4 matrices here. A, B, C, and D. What do you notice about them? What do you mean by that? Elaborate a little bit. Okay, let's talk about the names because you're looking at how many rows and how many columns there are, right? What's the name of A? What are the dimensions? Row by column, so we get 2 by 3. What about B?
3 by 2.
3 by 2. C? 2 by 3. D? 2 by 3. Now what do you notice? There's 3 that are the same. Which one's the oddball out? B is the oddball out, right? I'm going to ask you this. Could I add A and C together?
Yes.
Why? Because they're the same, right? Everything has its own, I'm going to say, partner. Okay? What about, can I add A and B together?
No.
Why not?
They're not the same. They're
They're not the same dimension, okay? If I try to let's say add 3 to something, is there anything I can add it to?
No.
No, because it's missing, right? Let's say if I tried to add -2 to something, is there anything to add it to? No. Okay, so something to write down, a little note to self. You cannot add matrices with different dimensions. You cannot add matrices with different dimensions. So let's talk about that for a second. Can I add a 3x4 with another 3x4? Can I do that? Can I add a 3x4 with another 3x4? Yes, because they are the same dimension. Okay. Can I add a 1x2 with a 2x3? No, why not? Not the same. Good. Can I add a 2x3 with a 3x2? Why not? Right. Yes, they are the same numbers, but is the number of rows the same as the number of rows? No. They have to be the exact same, just like this 3x4 and 3x4. Okay. Even if they're switched around right here, they're still different. They're not the exact same. Okay. So let's look at your example 4 here. It wants us to find R minus Q on part A. So R minus Q. So I'm going to start with 6 minus 2. 6 minus 2? 4. I should back up a little bit. Can I add Q and R together? Because they're the same dimension. Yep, this is a 3x2. This is also a 3x2. So we can add them together. So 6 minus 2 is 4. What about 0.5 minus a -2? You get 2.5 for that one. What about -3 minus 5? Get -8. 0 minus a -5. That turns to a +5. -2 minus a -7. So that turns into -2 plus 7. 5. And then we have -2 minus 7. Which gives you a -9. So we found R minus Q. An add-on question to that, it says, what other matrix sums or differences can we be calculated? So what other matrix pairs out of P, Q, and R can I add or subtract together? Is there any more? Why not? Right, can I add or subtract P and Q? Why not? What is the dimensions of P? 2 by 3, right? Can I add P to either Q or R? No. Okay, so are there any other calculations that can be made? Nope. Good. Next one. Part B is we want to find the additive inverse. Okay. Additive inverse of P. Remember that -1 means inverse. So, what do we know inverse? What's another word for inverse that we use? Opposite. So, for P, matrix P, what is the opposite of 5? -5. What's the opposite of 2? Yep. When I'm writing these, does it matter the spots I'm putting them in? Yes, they have to be in the same spot. What's the opposite of -3? 3. Opposite of 7? -7. Opposite of 0? Is there such thing as -0? No, just 0. And then opposite of -5? 5. That's the inverse of P. Okay. If I added these back together, what would I get? I would get the 0 matrix, right? Okay, go ahead and find the inverse of Q and the inverse of R.